Okay, today we are doing more about the quadratic formula. Yesterday we talked quadratic formula, and this was the hardest kind where we said, okay, here's a problem where we already know the quadratic formula. Well, what was the question? And it breaks down into three little equations. What little equation, don't just say the answer, what little equation could I write for that? 2a equals 10. That's a little equation, a little mini equation, which solves to a equals 5. How many of you knew that a was equal to 5? Good. The next one is this. What little mini equation could you write? Negative b equals 4. And then solve that. B equals negative 4. Good. We got a, we got b. Then the hard part is c. And then I hope you knew what equation to set up. Raise your hand if you've got the equation figured out for this last part. Okay, Mr. Q, what did you think? Perfect. And I happen to know b and a. A is 5 and b is negative 4. So negative 4 squared minus 4 times the a, which is 5, and the c, I don't know, equals 30. So then, from there, I just have to do some math. Negative 4 squared is 16, and that's a negative 20c equals 30. And then I'm subtracting 16 from both sides. Negative 20c equals 30 minus 16 is 14. And then c has got to be 14 over negative 20, which, yes, can reduce to 7/10, and it's negative 7/10, negative 0.7 if you want a decimal. Raise your hand if you were able to get it all the way. Nice work. I did not expect that. Okay, cool. Then, oh, wait. They wouldn't just do that. That'd be just too easy. They'd say, write the original equation. Yeah, it's not that hard, but just put it all together. Make sure you get that the answer is not done now. I have never even yet written the answer. The question was, what was the original problem? The original problem wasn't an A and a B and a C. The original problem was y equals Miss S. What did you say? Yes, the original equation was y equals blah, blah, blah. Not this one was x equals. You're right, that one was an x equals equation. But this answer I'm looking for now is the original problem that started this whole thing would have been y equals, it doesn't start with a squared plus b squared equals, or a squared plus b. Okay, that's great. You found c. My point is what you have found when you've got a and b and c is you actually have an equation. So tell me the equation. Come on, you can do this. Yes. Yes. That's it. Nice job. All you do is take the a and the b and the c and stick them into an equation. Do you get how it'd be easy for a kid to think they got done? They found a, they found b, they found c, they thought they're done? Well, if that's not the point. The point wouldn't have been, here's A, here's B, here's C. The point would have been, here's an equation, and then you'd get that quadratic formula for it. All right, so let's just do a plain old-fashioned quadratic formula, which finds the roots, the zeros, the x-intercepts. Okay? Here is, I'm going to cheat. I'm going to show you ahead of time. This is the equation all factored out. Do you get I could get the roots from doing that? That's called the zero product property, where I go, this has to equal 0, and this has to equal 0. Okay, and I can find my two answers that way. In fact, I'm almost done. Tell me how to finish. What do I do in this one on the right? Add 7, x equals 7. What do I do in this one on the left? Add 3 first, and then, good, x equals 3 over 2. I want you to prove that those answers are actually right by using the quadratic formula. Well, then what would the original A, B, and C have been? Oh, I guess you'll have to multiply this out to figure out what A and B and C are, and then you'll stick them in the quadratic formula. What do these always have to be equal to? Quadratics always have to be equal to 0 before you even start. I mean, that's how you start, is you get them equal to 0. So figure out what the original equation was. and then stick it in the quadratic formula. Hint, if you aren't foiling right now, you're probably not doing it right. Because you got to figure out what A, B, and C are. I'm going to pause while you give that a shot. Okay, here we go. So, you should have foiled this thing out. First, 2x squared. Outside, negative 14x. Inside, negative 3. And then negative 14 and the negative 3 make negative 17x. And then the last make positive 21. How many of you got that? Okay, good. Now you know A, you know B, and you know C. Now this happens to be kind of a nasty one because the numbers are so big. But if you just did the whole quadratic formula, x equals negative b, well, that's negative of negative 17 makes 17, plus or minus square root of b squared. Ooh, 17 squared. 17 squared minus 4ac. A is 2 and c is 21. All over 2a. 2 times 2 is 4. The weird thing is that when you simplify it all down, will come out to 7, and the other answer will be 3 over 2, or 1.5. But we have to actually multiply that all out to do that. Okay, so that ends up being a square root that is just unmanageably huge and nasty. Okay, so at least how many of you knew how to set this up and put that in there? Okay, good. Now I'm going to give you numbers that are really nice and easy. Okay, and we'll say that the x plus 1, x minus 3. There. Nice and easy. That's your equation. So I already know the answers are negative 1 and positive 3. But I want you to prove it with the quadratic formula. By the way, again, this method I used just right there, that's called the zero product property, ZPP. Because this is a product, and it equals 0 because y is equal to 0 because I'm finding x-intercepts. You're proving that the quadratic formula should work just as well as the ZPP. My ultimate method for solving quadratics is if you can factor it, you should. Because look at how easy that is. I already know the answers. Negative 1 and 3. And you guys are still working when you use the quadratic formula. The quadratic formula is slow, but it always works. Factoring doesn't always work. TS, what did you get for the multiplied out version? Mm-hmm.
X squared minus 2x.
You are so right. And then, when you put it in the quadratic formula, let's pick on Mr. S in the blue shirt. X equals negative b. I'm doing the quadratic formula right now. X equals negative b plus or minus square root, blah, blah, blah. B squared, which is good, minus perfect, all over 2a, which is awesome. Did you get it that far? Okay. Mr. M. I know it's your first name, but that's okay. Square root of 16. I know that one. So it's really 2 plus and minus 4 all over 2. And then you do it once with plus and once with minus. 2 plus the 4 makes 6 over 2, and that's equal to 3. 2 minus the 4 makes negative 2 over 2, and that's equal to negative 1. That's how my answers come out to 3 and negative 1. Raise your hand if that worked for you. Okay, good. Yes?
When I saw 2 plus minus 4 over 2, I divided the 2 with...
Okay. If you take the 2 out like this, you'd have 1 plus 2, plus or minus 2. Is that what you factored the top to? Okay, good. Then if you do that, this 2 will cancel this 2, and then it's either 1 plus 2, which is 3, or 1 minus 2, which is negative 1. So it still works. That's cool. Yes?
Wouldn't it be negative 2 at the beginning of the formula?
All right. It is negative b, right?
Yeah.
But b is negative 2. So it's negative of negative 2. So you tell me. Get what I'm saying? It's negative b, and b is negative, so when you have a negative negative, it becomes positive. Okay. So that's covering some of the toughest stuff that you have done so far, and you guys are coming through with flying colors. It's a good sign. All right. Let's now get into the homework for last night. Everybody take it out. We're going to grade it. I'm going to pause for a second while we do that again. All right. Quadratic formula with applications is officially today's topic, and so of course you're going to end up with the quadratic formula solves your problem usually. So let's see how we can apply that. And this is the hottest place on earth question. That's just kind of like a quiz question. By the way, is it Death Valley? Nope. Apparently there's a place in Libya that was 136 degrees. Holy smokes. I actually have an interesting story about this. I met a guy who lived in Jordan. Okay, it's a country near the desert, and they had a tradition of if it got colder than 80 degrees, like it could be 80 degrees out, and people would wear jackets because they're so used to temperatures like 120. Now think about it, it's 40 degrees colder than normal for them, right? At 80, they put on a jacket. Isn't that insane? So like 40 degrees lower than normal for you is like what? Well, what's Minnesota normally? Like 70 maybe on average? So you go down 40 degrees and that's like what? 30, and that's cold, right? You put on a jacket. Same thing, except it's 120 normally, and so people get cold when it gets down to 80. Isn't that a weird thought? All right. So this is just a little quick review. We've done a lot of this. Would you please factor that top part and then cancel what can cancel? Factor, then cancel.
Sorry, but what if those guys came to Minnesota?
That's true. There are some people who come from foreign countries to here and then think, like, why do people live here? And you're kind of used to it. And I will say over time, I think older people tend to get like less and less patient about the cold. And that's why a lot of them, a lot of them go to Florida. Like a lot of retire to Florida and stuff, because I think as you get older, you get less able to handle it. When you're young like you guys, it's not that big of a deal. Some of you are like, I can't handle it either. Get me out of here. But anyway, bottom line is, I think there's a correlation between age and desire for warm temperatures. All right. So 3 comes out of this, and you should have said 3, and then a 2 plus or minus square root of 5 all over 3, and that makes it cancel. So the answer is just 2 plus and minus the square root of 5. Raise your hand if you got that one right. Okay, good. All right. I've done enough review, and we did some review before, so we did that kind of thing. And we're going to jump right to, there we go, applications with quadratics. So the maximum height here, also known as the vertex, right? That's one of the big 3 things we can ask you for. So if we say, what's the max height, you should just think, oh, they're asking me to find the vertex. Didn't we have a vertex CTS? What did the CTS stand for? Complete the square. If you need the vertex, you can complete the square. Other option, you could graph it with your calculator and find the place where it was the highest. How do you find a max like this? It's on your calculator, second calculate maximum. That's a place on your calculator. We'll show you that in a bit. All right, where is it at a given time? That's like, okay, the ball's been in the air a total of 4 seconds before it hits the ground. Where was it at like 3 seconds? Well, it's like somewhere in here. And the last kind of question they can ask is when it actually hits the ground. When does it hit the ground? Notice it's not where does it hit the ground, it's when. This is time down here, and this is height. All right, so those are the 3 major kinds of questions that they can ask you. All right, so here's an equation. For a ball, that is flying in the air, and after a certain number of seconds, you can figure out where it is. Why does the ball not start on the ground? Because this is not golf. Do you get in baseball, the ball gets kind of launched from a bat, so it starts off the ground. And then when you hit it, generally you don't hit the ball straight, you know, like with no height. It adds height when you hit it. The height goes up. And then it reaches its highest height, and then the ball starts to come back down again, right? And eventually the ball hits the ground. And notice this is not where the ball hits the ground. It's what? When the ball hits the ground. Okay, so what we've been asking before is like, what's the vertex? What that would be in the context of the question is, what's the highest it went? We also have asked you for these things. There are 4 names for that spot. What is it? Vertex. Roots. Not the vertex. The roots, the x-intercepts, solutions, the zeros. Okay, good. That's all the same thing. And if you can factor it, you should. And see if anybody's picked up on this yet. If you can't factor it, quadratic formula. So to solve for this, if you can factor your equation, you factor it and you find the zeros, and it'll be like this. And then you go, oh, the 2 answers would be -4 and 4. And the one that's positive, because time can't be negative, would be 4, and so therefore the answer is 4. But if you can't factor, quadratic formula. And I have to add a third thing. If you can factor it, you what? You should. If you can't factor it, what? Quadratic formula. And the third thing is, if you've got a graphing calculator, you can always graph both sides and what? And see where they cross. Any equation, even if it's as simple as this, if you graphed both sides, there's going to be 2 lines. Wherever they cross, that's your answer. So if you want to graph this and graph both sides and see where it crosses, think about it. It's y equals this as one side of the equation. But what's the height when the ball hits the ground? What's its height when it hits the ground? 0. So it's really another one of these where you set it equal to 0 because the ball has hit the ground. And if I'm graphing both sides and seeing where it crosses, y equals 0 is one thing you graph, and y equals 16x, or -16t squared plus 25t plus 5 is the other equation. You graph this, you graph y equals 0, and you see where they cross. It'll look like this. And you see where the 2 lines cross. What's the other line? Y equals 0, it's that line. So it's really, you're finding the roots, the zeros. And can you have negative time? No, so you always throw out that answer because that one just doesn't make sense. It's called extraneous. And the answer would be wherever it touches like that. All right, so in order to do this one with a graphing calculator, you would have to just type that into your calculator and now see, let's actually do some of that. Everybody grab a graphing calculator. I'll pause for a second while you do that and type that puppy in to your graphing calculator. Paused. All right, so I have got my equation in my calculator, and the weird part is that when I hit graph, I can't see the top. So how do I fix that? I go to my window, and I say, I want to be able to see higher. Is higher an X thing or a Y thing?
Y.
Y. Y max. Y max is only 10. Let's make it bigger. Always go bigger than you think. So I'm going to make it like 25. And then I'm going to hit graph. You can do whatever you want. Okay, there. Now I can see the whole parabola. Now, do you get if they were asking me for what's the highest the ball went, I got to find the max? Everybody hit second. That's that blue key in the upper left. You with me? Second, calculate maximum. It's the 4th thing down there. Second, calculate maximum. Does it just jump right to the maximum? I wish. It will now ask me for 3 things. It'll say go to the left of it, left boundary. Am I to the left of the highest spot right now? Okay, I did second calculate maximum. You got to stay with me.
Is it calc or
Second calc, it's right above trace.
That's what I did.
Second calc maximum.
Oh, okay.
All right, now I'm on the left boundary thing. As soon as I get to the left of it, I hit enter. My calculator puts in a neato dotted line there. Some of yours will, some of yours won't. Depends on the operating system you have. Then I'm going to go to the right of it. I am now to the right of it, and I hit enter. Some of yours will only put in like the little caret at the top. Mine puts in the little caret and a dotted line. Again, it's saying, I'm going to tell you the max between here and here. And whenever the calculator says guess to you, it's saying you should guess where it is. I think that's where the maximum is. So I hit enter. And it jumps to the exact right answer, which is 0.78 and 14.76. Does that mean I have 78 cents and I get 14.76 koalas? No. In the context of this question, what the heck does that mean? What does 0.78 mean? That's how many what's? Seconds. And what's the 14.76? The height. All right. Second, calculate maximum. All right. There's one other thing I got to show you. Listen, please. Listen, please. All right. If you want to find where it is at any given time, like let's find where it is at 1 second. We go, watch, this was like the last one. Second, calculate, it's up here. So you didn't ever find the calculate button, it's that one, it's red right now. Second, calculate, which one do you think we want if we want to set an x value, like that's time? Nope. Value. The very first one. Do you get that they list these in order of the how often people use them? The number one thing people use is value. The second often thing people want is the zeros. The third thing that people often want is the minimums. The fourth thing, the least most common, is the maximum. Actually, the least most common is the intercept. And you don't even know what the other thing is. It's called a derivative. You'll get to that someday. All right, so I want the value. That's an x value. Watch what happens when I say second calculate value. See it has this x equals blinky? It wants an x. In the context of this problem, x is time. It wants me to tell it a time. What time did I say before? 1. So I'm going to hit a 1. Enter. And watch, it jumps right to, at time 1, y is 14. Yes? Okay, that means your window was not able to see your maximum. Remember me talking about how we had to change the window to make it tall enough so you can see the maximum? Otherwise, it won't work. All right, so back to, if I want to say, when did it hit the ground? Do you get, I'm trying to find this spot right there. All right, so do you remember me saying that you graph both sides of the equation and see where they cross? Graph both sides and see where they cross. How did I only have one thing. What's the other side of the equation? It's the h. What is h equal to? 0. So I'm going to graph the other equation as just y equals 0. Now I have two equations in there, and when I hit graph, my calculator will actually show it because it can use different colors. Yours probably you can't even see it because it's a black line that's on the x-axis, and you won't be able to even see it's there. Everybody type in that second equation if you haven't already. You should now have two equations. The top one, and then y equals 0 is your other one. Okay, and when you hit graph, if you want to see where those two things cross, you go second, calculate the intersect. That's number 5. Everybody do that, please. Second, calculate intersect. Now, here's the catch. There's 3 questions, and they're kind of confusing. Here's my best way to tell you. Get really close to where the two lines cross. That's as close as I can get. And then just hit enter, enter, enter. And it'll jump to that spot. 1.74 and y equals 0. In the context of this question, y equals 0 means height equals 0. That means it just hit the ground. What is 1.74? The number of chickens that I have? It's the time. 1.74 seconds is when the thing hit the ground. Okay, you typed in the equation wrong. Simple as that. All right. So, nope. Okay, I thought you were coming up to get mine. I can't help you with your calculator issues right now. All right, so
There you go.
for the moral of the story today is I needed to teach you how to find a few things on your calculator. And I know some of you maybe had some issues with your calculator. At the very beginning, I encouraged you to clear it all off so you could just have a simple, make sure your calculator works. And then if you need to, you can always go back and watch this video again to see how to find maximums and time And when the ball hits the ground was second calculate intersect. That's the way I like to do it anyway. You can also do second calculate the 0. All right. Your homework for today is this worksheet right. It's not there. Get back to it. I'm going to pause for a second while I find what the homework. It's applications worksheet A, and it's problems 1, 2, 3, and 7, 8, 9 are the ones that I want you to focus on. That's all I got for you for today.